Hello and welcome back to the course on artificial intelligence. In today's tutorial, we're talking about the final A in A3C. We're talking about advantage. So there it is. We've already spoken about actor, critic, and asynchronous previously, and slowly built our way to what we're going to be looking at today. And with advantage, we're going to put everything together. So this is what we have so far. We've got a neural network which is shared between the agents, the asynchronous agents, and then we've got the critic, which is also shared between the agents. So how does this all play out, and why is this critic shared between the agents? Let's have a look at that. Well, understand this better, we're going to look at an example. We're going to look at this agent, for instance, and see what happens when he's in a certain state and he needs to make a decision what action to play. So this agent is in a state, he sees this image, and then what happens is this information goes into the neural network, it goes to the convolutional layer, then it goes into the pooling layer, then it goes into the flattening layer, and then from there it goes into the hidden layers of the neural network. And then as an output, he gets all of these policy values, the Q values of the policy, and also he gets the V value, the critic value. And so, as we know, neural networks, in order to operate, they need to propagate certain errors or losses back through the network, so this way, in order to update the weights. So what losses are we going to be dealing with here? Well, we've got two losses. We've got the value loss and the policy loss. So the value loss is linked to the V value, policy loss is linked to policy. And so value loss, we've already dealt with it before. We know that we have rewards and we know that we have a discount factor. So basically, this is very similar to what we were talking about in the deep Q-learning tutorials. Basically, the network predicts a certain value V, and at the same time, we can estimate what should be, based on what we know about the environment so far, we can estimate what should the value V be in the state. And by comparing the two, we can calculate the value loss and then backpropagate the network, update the weights. So that's pretty straightforward. The new thing here is the policy loss. And so what is this policy loss and how does it work? Well, this is the part where this whole situation where the critic is shared between the actors or between the agents is going to finally emerge. So to understand policy loss, we need to introduce a value called advantage, hence the name of this part of this tutorial and this whole part of the A3C algorithm, the advantage. And the advantage is calculated as Q of S and A minus V of S. So basically, the Q value that you chose to play, of the action that you chose to play in the state that you were in state S, minus the value of that state. So this is the difference between the two, and that is called advantage. And the advantage is used in the calculation of the policy loss. Now, we won't go into the formula of the policy loss calculation because it's quite complex. It uses entropy, or it can use entropy, doesn't have to. We're not going to dissect that formula, but we're going to understand this on an intuitive level. Why are we doing this? Why are we calculating this advantage, and how is it going to help us? Well, let's look at this for a second. The Q value here comes from what the neural network predicted for this agent. So it predicted in this specific action, in this specific state for the action that it can play. So it's got these actions and it can select one of them and it can play it. Well, whereas the V value is the value that is dictated by the critic. It is the value that we have here in this shared part. And that's the key here, that this part is shared. So the critic, because this is how the critic comes into play, because we've got a value that we choose, or the action that we choose to play for this agent in that state, but then the critic can tell us what is the known value of that state. What is overall the known value for this whole group of agents that are performing together, because they're sharing, not necessarily because they're sharing the network, but because they're sharing the critic, they're all contributing to these V values that are being calculated for a different state. So the whole A3C algorithm says, okay, so the critic knows a V value. How much better is your Q value that you're selecting compared to the known V value? That's what it's saying. So that's basically it. So that, okay, I'm going to select a Q value here based on my policy based on whatever we use, like a softmax function or a epsilon greedy policy or something like that. And of course, there'll be exploration plus exploitation combined in there. But we select a Q value, and now the question is, what is the advantage? Hence, it's called advantage. What is the advantage that your selected action brings compared to the known value of that state? And that is the essence of the advantage. And basically, then that is used to calculate the policy loss. And then the policy loss is then backpropagated back through the network. So they're both backpropagated through the network, and the weights are adjusted in order for the network to better represent the value of the critic. And also, so that's this top part. But then this also part, the key here is that the weights are when this policy loss is backpropagated, the weights are adjusted in such a way so that this advantage is maximized. So like that's the intuitive side of the intuitive understanding of it, that we are backpropagating this policy loss through the network in order to help maximize this advantage. And what that means is basically that when an agent comes across bad actions, like actions where the Q value is less than the known value for the state. So basically the whole A3C algorithm knows that the value for the state is something, X. And then all of a sudden you came across a very bad action, and you chose a bad action. And what that means for the A3C algorithm means that, well, why would we do something like that when it's worse than what we already know about this whole environment and what we could have done? So we shouldn't do more of that. And therefore the weights are adjusted in a way so that happens rarer, so that happens less rare. So that's a less frequent occurrence that we choose that bad action. On the other hand, if you choose a very good action where Q value is greater than V or much greater, then during this backpropagation of the policy loss through the network, the weights are going to be updated in such a way to reinforce that, to reassure that to happen again, so that the weights will be adjusted in such a way so the A3C algorithm will think, oh wow, that was really cool. The advantage was very high there. I should do more of that, and therefore it will update the weights in such a way that will be more likely to occur in the future, that action. So, and therefore that is that's how the network is slowly going to adapt and slowly going to construct itself into something that on one hand calculates the value correctly, and then on the other hand, or as correctly as possible, and on the other hand it encourages, or it has actions which have a high advantage. So there we go. That's this part. And now let's have a look at another one just to kind of reinforce what we just discussed. So let's look at the top one. So same thing here. The top agent sees a situation, a state is in a state, and then needs to decide what to do. So sends this information to the network. So this image goes into network, goes to convolutional layer, pooling layer, flattening layer, goes into the hidden layers. And then from here we get an output. We get the Q values of the policy, we get the V values. Again, the same thing. We've got two losses. We've got the value loss, which is here, the policy loss, which is here. Value loss, we already know how it's calculated. We discussed this in the deep Q learning and just discussed it just now as well. So that's how the value loss calculated. And then the policy loss, again, in order to calculate that, which we're not going to go into formula, but on an intuitive level, we're calculating the advantage, which is, okay, so we took a certain action, we chose a certain action based on our selection policy, whether it's softmax or epsilon greedy or whatever other selection policy that we're using. And then what's the action we took? Now let's compare it to the known value of the state, which comes from the shared critic. So this critic is kind of like, if you think about it, he's kind of observing all of these agents at the same time. He's looking at this one, looking at this one, this one. They're all contributing towards the critic to get the critic more up to speed with the environment, to make sure that the critic is representative of what's going on in the actual environment, so that the weights, that's where the value loss comes in, so that the weights of the actual neural network, that they reflect very well the actual situation of things in the environment, so that they can then rely on this value and then use it here. And so basically, so all of these agents, agents are contributing to this critic, but then at the same time, through this value loss, but at the same time, the critic is observing the decisions or the policies of these agents. Like, it's like looking back at like I'm trying to draw like an arrow to the policy, an arrow. It's looking back at them, at the decisions that they're making. It's criticizing these decisions through the advantage. It's saying, okay, you made a decision, you chose this action. That's great. Now let's calculate the advantage. What is the advantage? The advantage is A equals, the Q value of made the decision I made, or the choice I made, the action I made, chose to take, minus the known value to the critic, So calculate the difference. If it's a low difference, then when your policy loss is backpropagated through the network, the weights are going to be adjusted. It's going to encourage the weights to be adjusted in such a way that doesn't happen again. That Q value, or that Q value is going to be lower, so that because our policy selects the actions based on the Q values. The higher the Q value, the more likely it's going to be selected. So if we were using like an argmax policy, then we'd just always select the one with the highest. As you remember, we discussed this. Then we'd always select the one with the highest Q value. But we're using a probabilistic approach, whereas either using like softmax or epsilon greedy policy. And then, so we're basically selecting, we can select any one of them, but the higher the Q value, the better. So if we selected something and then the advantage was very low, then bam, the network is going to be updated in such a way that next time this Q value of that certain action is going to be less, and maybe something else will be more. So that's how that is played out. And on the other hand, if we select something where the advantage is going to be high, then this is going to go into the policy loss, and then the network is going to be updated. So that is a more commonly observed scenario. And so basically, this whole policy loss helps the network adapt or morph in such a way that we do more of the good stuff, good actions and good things, and do less of the bad things. And that's how these two losses come into play, and that's how they backpropagate. So hopefully that clears up in a very intuitive way. Of course, we didn't go into the formulas, into the complex mathematics behind all of this, and like into the very intricate details. But at the same time, hopefully in an intuitive way, all of this clears up why we have the actor and the critic and how they interact together. That, you have these agents asynchronous. So this is the synchronous side of things. Then this is your actor and your critic, and this is your advantage, and how that all comes into play. So these asynchronous agents, they're playing this or exploring the environment and working through the environment, and they're all together contributing to a critic, which is then observing their policies, observing the actors, which is what this is called, and through the advantage, and therefore coming up with this policy loss, and then policy and value loss, they're backpropagated to adjust the network in order to, on one hand, represent the true way of things in the environment, on the other hand, to improve the actors' performances. So there we go. That's a quick recap of the intuition we discussed. And once again, hopefully this is all coming together on an intuitive level. And of course, in the practical tutorials, we'll talk more about how all of this works, and Adlan will walk you through the process of building this. But having this image in your mind and this kind of like a roadmap of everything, how it comes together, should be, I hope it'll be very helpful for you to better navigate the practical side of things. And in terms of additional reading for today, we've got two elements. So first one is on the advantage. So here we've got high dimensional continuous controlling using generalized advantage estimation by John Schulman. And this is an image of a stick figure getting up, like standing up. And here you can find even more about advantage, and you'll find out the different types of advantages. So you've got the generalized advantage estimation. You've got advantages that you use actually in the formulas, in the calculation. So if you want to find out more about advantage and exactly how it works, the formulas behind it, and some of the top elements or formulas and know-hows in the space of this advantage that we discussed, then this is the article to go to. And one other element that or piece of work that we wanted to remind you about is a series of blog posts by Arthur Giuliani, which we've mentioned a couple of times already. This is part 8, which is specifically about A3C. So here you can get another explanation, so with a bit more mathematics about what's going on, and maybe you can pick up some additional things from here. Just 2 things to keep in mind. First of all, as always, this blog is in TensorFlow, whereas we're using PyTorch, so keep that in mind. And the second thing is that the way we structured our approach is we talked about actor critic first, then we talked about asynchronous, and then we talked about advantage. Whereas in his blog, Arthur first talks about asynchronous, then actor critic, then advantage. So keep that in mind. So hopefully that doesn't throw you off. But other than that, of course, it's a great piece of content, and we do highly recommend checking it out for some additional information. So there we go. Hopefully you enjoyed today's tutorial, and I look forward to seeing you next time. Until then, enjoy AI.